Welcome everybody. Glad you could take the hour out of your day to spend with us. We talk about multi-row fetch and ways you can improve your application performance by adopting multi-row fetch. As John said, my name's Craig Mullins. I'm a consultant with Mullins Consulting. A lot of you may know me because of my book, The DB2 Developer's Guide. Real briefly, just want to let everybody know that the 6th edition of this book, covering through version 10, will be out in early May of this year. So if you've got earlier editions of that book and wanted something updated to version 10, you should get it soon. So what are we talking about today? Well, we're going to talk about multi-row fetch and accessing multiple rows at one time instead of row by row, the way you traditionally do it. And this has been available since DB2 version 8. And I know a lot of times a new feature will come into DB2 and we don't take a lot of time to try and figure out how we retrofit it into old applications. But this is one where you really should take some time to figure out how you can do that. So in this presentation, we're going to talk about what is multi-row fetch, how does it compare to a regular fetch, how do you use it, what are the performance implications of doing it. We'll talk a little bit about multi-row update too, but not really going to focus in on that so much. And at the end, we're going to introduce a new feature of SoftBase's attach facility that will allow you to implement multi-row fetch in your applications without changing the application code. And that is really what is probably stopping a lot of you from going back and retrofitting it into your old programs, because you got to go in and change the application code. And we all know no one wants to go and change application code if they don't have to, right? You know, if it ain't broke, don't fix it. Even if you can get performance out of it, it's kind of tough to go to your manager and say, I want to go and start working on this program that is working, and I can make it faster. And they'll say, yeah, well, there's other things we can do. Now you can make it faster without changing the code. So we'll talk about that at the end. Here's the agenda. I'm not really going to go over this in any detail. I want to just dig right into it. So let's start out. What is a multi-row fetch? Well, what it does is it allows you to retrieve multiple rows at one time into arrays in your application program. So if you're used to coding up a cursor and fetching a row, every time you fetch a row, you get one row back. With multi-row fetch, every time you fetch, you get multiple rows back. Okay, that's high level, but maybe we've gotten a little bit ahead of ourselves. So I really want to go back and define some basic terms quickly here with relational closure. You really need to remember that when you're writing SQL, you have to think in sets. And what relational closure means is that all operations that are performed on a table result in another table. And a table is a set of 0 or more rows and 1 or more columns. So you start with a table, you end with a table, and that's the beauty of the relational database. Set versus record level processing. This is why you need a cursor when you write SQL selects. Usually you can write a singleton select, but usually you're going to get multiple rows back. And application programs operate a record at a time. You know, don't think database, just think going out reading from a file. You know, we're going to read a record at a time. But SQL operates a set at a time. So I say select, and it comes back and says, here's all of the rows that satisfy that select. Conceptually, that's what it's doing. So SQL is set processing, whereas our application code is generally written at a record at a time of processing. So that's why we have cursors, right? All a cursor is a pointer, a moving placement that indicates a position. In a DB2 program, you use that cursor to step through the results of a select statement. So we code up a select in a cursor and fetch row by row from it. Each statement that you issue is going to return 0, 1, or more rows. You'll get SQL code back if you got 0 rows. You want to get to the end of the cursor. And basically, we just take this result table and fetch from it a row at a time. Okay, so we got relational closure, set versus record at a time processing, and what a cursor is, if we go back to multi-row fetch, it returns blocks of data instead of a single row at a time. And a block consisting of multiple rows gets returned to that program and places the rows into an array. That means that the program has to be coded with that array, and that the data is then accessed by traversing the array in the program's memory. And you do that instead of fetching a new row for each iteration of your program logic. So instead of fetch, 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 we fetch and then bounce through the array. When the program exhausts the data in the array, another fetch is issued, which returns another block of data, and we repeat the process again. Okay, so let's move on and take a graphical look at the difference between a single row fetch and a multi-row fetch program. Traditionally, when an application executes an open cursor statement, DB2 is going to create a temporary result set of requested data. Once this result set is created, the application has to execute a fetch statement for each row of the data in the result set. The number of fetch statements executed can be a few, a couple hundred, tens of thousands, maybe even millions. And each of those fetches is a whole series of machine instructions. For a batch application that accesses a significant number of rows, we're talking thousands or millions, the fetches that have to be executed can really put a impact on the system. It can constitute a rather resource-intensive process. It's resource-intensive, is what I'm trying to say. Multi-row fetch, on the other hand, which again came out in version 8, allows fetch statements to dictate the number of rows returned from DB2 for each fetch statement. What this does is it reduces the number of times that DB2 has to be called. And by reducing the communication between the program and DB2, we're reducing overall overhead. As I indicated earlier, the application has to be designed to handle multiple rows being returned. For applications built for single row fetch processing, rewriting that application to handle a multi-row fetch is probably more than a trivial task and more than you want to undertake in many cases. And it's going to require some amount of coding, some amount of testing, and take time and resources away from your development effort. So why do it? Well, using multi-row fetch, you can greatly decrease the amount of CPU required because it reduces the movement of data across address spaces. And moving data across address spaces can be an expensive process. Multi-row fetch moves multiple rows with a single operation instead of a one at a time with a row at a time traditional cursor.